Hey, hello everyone. Welcome to the next video on power systems. In the module 4 underground cables, this is the lecture number 3, capacitance of single and 3-core cable. I'm Ganesh, assistant professor in electrical engineering at Kekewag Institute of Engineering Education and Research, Nashik, India. So let's begin with the content. In the today's video, we are going to see the capacitance in the cable, then capacitance of the single core cable, capacitance of the 3-core cable, and measurement of capacitance in the 3-core cable. What are the learning outcomes of the today's session? At the end of this session, the learner will be able to derive the formula of capacitance in single core and 3-core cable, justify the measurement process of the capacitance in 3-core cable. Okay, so this is the learning outcomes. Let's begin with the reflection point. Which statement is true about the capacitor? When there is conducting material between two dielectric plate, it forms capacitor. When there is a dielectric material between two conducting plate, it forms capacitor. When there is air between two conducting plate, it forms capacitor. Okay, so pause the video and guess the correct answer. Please read the question carefully. Hope you got the correct answer of this question. To form a capacitance, we always require two conducting plate and insulating. So this is the conducting plate. Okay, and this is also the conducting plate, and in between two conducting plate there must be insulation. That insulation may be a dielectric material or it may be air. It may be air. Okay, in overhead transmission line between two conductors there is air is a media, hence the capacitance is also formed. In overhead transmission line air will be act like a insulating media, hence the capacitance in form is overhead transmission line. So how this will be in case of cable, that we will see. So let's introduce about the cable. So this is the construction of the single core cable. We know that this is what my, okay, so this is my core. So I will mark this with the core, and this is sheathing which is done here, or you can say it is armor also. Okay, sheathing. And generally this sheath is connected to the ground. Okay, this metallic part, and you will observe that this is the insulating material. Here it is insulating material. So as this is connected to the ground and conducting is having some potential over here, obviously there is insulating material in between the two conducting plates, and it forms the capacitance. So let's introduce the cable. Capacitance is defined as the measurement of electrical charge stored in. What will be the charge will be stored in this capacitance? That is, capacitor in the cable is constructed by two conductive material. This is one and this is another, separated by an insulator or a dielectric. Capacitance of the cable determines is used to determine the charging current. Why it is required? Because the charging current is a very important parameter when we are exciting the cable on the no load also. So what amount of the charging current capacity this cable will take, that is important. Then charging kVA and the dielectric loss. If your charging current is more, your receiving end voltage will be more than the sending end voltages. That will cause a problem at the equipment of other end, so that it is necessary to determine this charging current. Hence the capacitance must be known. The capacitance of the cable transmission line is very large than the overhead transmission line. This cable capacitance is very high than the cable transmission line, because the distance between the plate in overhead transmission line, distance between the two conductor or distance between conductor to earth is very high. But in this case, if you observe that the distance between the two conductor is very low, that's why as the distance is very low. Second one, the distance between the core and earth sheath, distance between conductor. Okay, so in the three phase, suppose we have a three conductor, between the two conductor also, in a three phase between a two conductor also there is a very less space, and in conductor and sheath also there is a very less length. Permittivity of the cable. So in the in for overhead transmission line, the relative permeability is 1 because air is insulating material, but here we are use relative permittivity is 1. But in this case the relative permittivity is generally lies to 3 to 5 because of the insulation which is used in the cable. So this this is 3 to 5 relative permittivity of the insulating material of the cable. Okay, so again we have a reflection point. You have to answer this question. Pause the video for some duration, think over it and answer. When two conducting plates of cross sectional area of a square meter are separated by the d meter with dielectric medium of relative permittivity epsilon r, the value of the capacitance of the capacitor form is. So what is the given in this problem? So we have two capacitor and the area of this is a meter square. The distance between two plate is d, and the insulating material which is filled in between, that is having the relative permittivity of epsilon r. So you have to determine what is the value of the capacitance between these two plates. So these are the some formulas. C is equal to epsilon 0 epsilon r a divided by d. C is equal to a divided by epsilon 0 epsilon r d. C is equal to epsilon 0 epsilon r d divided by a, and C is equal to d divided by epsilon 0 epsilon r a. So guess the correct answer. Pause the video and guess the correct answer. I hope you have studied in this in the first year of your engineering. Okay, hope you got the correct answer. So let me give the answer. It is the capacitance is always, in this case the capacitance is the proportional to your area and inversely proportional to the distance, and it is also it is depending upon the material. Hence the capacitance is given by epsilon 0 epsilon r a upon d farad, where epsilon 0 is 1 upon 8 1 upon, okay, so epsilon 0 is 8.854 into 10 raised to minus 12 farad per meter. Okay, so that is the what relative absolute permittivity. It is known as absolute permittivity. Okay, but in case of overhead transmission line, your this epsilon r is equal to 0. So sorry, epsilon r is equal to 1 because relative permittivity of the air is equal to 1. So relative, in case of overhead transmission line, this epsilon r is equal to 1, but it is in this it is a significance since the value of the capacitance is high. Okay, so distance is low, area is not in your hand, but permittivity is also high, so that capacitance value is high. So how to calculate the capacitance of the single core cable? So this is the construction of the single core cable. So let's draw the cross sectional view of this construction. So let the conductor having the radius r, and your sheath is having the radius capital R. Okay, and I'm taking the cylindrical cut section in between at x meter distance in the insulation with the thickness of dx, with the thickness of dx. Okay, so at the x meter distance I'm taking the cylinder of the distance 3x. So this will be a cut section of the cylinder likewise, and let the length of this is equal to L meter. The length of this is equal to L. We will take in this case 1 meter for a simplicity purpose. So we will take the length of the cylinder is equal to 1 meter. So let R is the radius of the conductor. Capital R is the radius of the metal sheet. Epsilon is equal to epsilon R0, epsilon 0 into epsilon R, that is the permittivity of the dielectric material. Let x is the cylinder with axial length of 1 meter. This is the axial length of 1 meter, and dx is the small cut section into it. So how to calculate the surface area? So surface area of the cylinder. Okay, so the surface, I want to calculate the surface area of this cylinder. So what is the radius? Radius is the x, and the length is equal to 1 meter. Okay, so sir, we know that the surface area of the cylinder is given by a is equal to 2 pi xl, but the length is equal to 1 meter, hence it is a 2 pi x meter square. So how to calculate the flux density? We know that the density is always given by your charge. Here it is a capacitance, so it is a charge, your charge divided by cross sectional area. So that is a q divided by a. So D is equal to, at x meter distance, D is equal to Q upon A, where A is equal to Q upon 2 pi x. A is equal to 2 pi x. It is a coulomb per meter square. That is electrical flux density. From this electrical flux density, let us calculate the electrical field intensity. Electrical field intensity is given by dx upon epsilon, that is dx upon epsilon 0 into epsilon r, substituting the value of the dx. So at point x, the electrical field intensity is Q divided by 2 pi x epsilon 0 into epsilon r volt per meter. Okay. So I want to determine, okay, so let's come to the next slide. I want to determine what is the potential difference between the conductor to sheath. Okay, so obviously the take the charging current means the potential at this point is different than the potential at this point. This is nothing but the work done from bringing the unit positive charge from this surface area to this surface area. That is the work done. So how to calculate this potential difference? This potential difference is given by, okay, this potential difference is given by V integration of your field intensity Ex with respect to dx, where x is varied from r to capital R, small r, that is the surface of this to the radius of the sheet. So r to r, substituting the value of Ex, that is a Q divided by 2 pi x epsilon 0 epsilon r. Q 2 pi epsilon 0 epsilon r are the constant taking outside, 1 by x dx. So integration of 1 by x dx is the ln. So if we take the integration of 1 by x dx, it will give you natural log of x. What are the limits? The limits are small r and capital R, substituting the upper limit plus ln r minus ln of r. So using the logarithmic property, it is ln capital R divided by small r. In terms of diameter also, we can take it as a capital D by small d. If the diameter of the conductor is a D, suppose this diameter is D and this total diameter is the capital D. Suppose we take the diameter. In some books are referring the diameter. I am giving the formula here with respect to the your radius. Okay, so the formula will not be changed. What is the capacitance of the cable? We know that the capacitance is equal to Q divided by V. So Q divided by, substituting the value of V over here, so Q divided by 2 pi epsilon 0 epsilon r, natural log of R by R, ln of R by R. So Q will be get cancelled. So this term will transfer in the numerator. So coming to the numerator is 2 pi epsilon 0 epsilon r, natural log of R divided by R. It is a farad per meter. Okay, because we have take the axial length of 1 meter, hence it is, I am saying it is a farad per meter. So what is the value of epsilon 0? Well, value of epsilon 0 is equal to 8.854 into 10 raised to minus 12. Multiply it with the 2 pi, and if I take the 1 upon 2 pi epsilon 0, you will get this value. So it will comes to epsilon r is as it is, and value of this 2 pi epsilon 0 is taken as the 18 into 10 raised to 9 natural log of R by R, farad per meter. Again further I can reduce, because farad is a very big unit for this, because this capacitance is generally in the microfarad and per kilometer. So per kilometer wise it is epsilon r. So to convert this farad into microfarad, we have to take it as a 9 10 raised to minus 6, and kilometer to meter 10 raised to minus 3. By taking all this, so this 10 raised to minus 9 will be get cancelled, hence it is 18 natural log of R by R. This is the very simplest formula to calculate the capacitance of the single core cable. But generally the single core cable is very less used in the field. We are generally using the three core cable. So in the three core cable, you will observe that there are the three conductor, and between each conductor we have a insulating material, and also there is a, between the sheath and conductor there is insulating material. So let's draw its the diagram. So we'll observe that, so three conductor, between the three conductor there is insulating material, means between these two also the capacitance will form, between these two also the capacitance will form. So let us consider that this is the conductor A, this is the conductor B, this is the conductor C, and this is the sheath. So you will, the capacitance will form in these two, this two, this two, as well as the capacitance will form between these two and these two. Okay, so this capacitance will be formed. So there are three in the three core cable, capacitance is formed between the each two conductor. Such three capacitances will be formed between the each two conductor. So this is the 1, 2 and 3 capacitance will be formed, which is known as the core capacitance, core to core capacitance. Hence the name is given as a CC. Also, the capacitance is formed between each conductor and sheath. So each conductor and sheath. So I will call this capacitance as the CS because it is formed with respect to the sheath. Okay, it is also in farad per meter. Um, it is also total 3 because with respect to each conductor, sheath will form a capacitor. Okay, so this is the what each conductor with the sheath capacitor, the total 3 capacitance will be formed in this case. Okay, so let me erase all this stuff. Okay, what is the capacitance? Okay, so we want to determine, so we develop the model of this capacitance of 3 core cable. So let's check. uh, let's play it like Tom and Jerry. So this outer circle, if I bring this outer circle here, so we have a 3 points and between outer circle over here. So between point A, point B and point C, or rather you can see this is a point B and point C, we will form one capacitance over here, which is the CC capacitance. One capacitance over it is a CC capacitance, and one capacitance over it is a CC capacitance. And the outer sheet I'm taking as a point. So between A and S, this is form a capacitance. Between C and S and between is, so it is S point or neutral point. I will call the S point or neutral point. So it will form a one capacitance. This capacitance is CS, that is a sheath capacitance. So same diagram I can reduce for modeling purpose. Same diagram I can reduce as like this. Okay, so I will call this S as N point. So CS, CS and CS. Now in outer delta, so you know that is outer delta having the capacitance of CS, CS and CS. So let's time being we assume that CCC, converting that point into the star, converting that point into the star. Okay, so what will be the equivalent capacitance here? So C into C divided by, to calculate this capacitance, C into C divided by, how will calculate it? C into C plus C into C plus C into C. Okay, so this will give you C square, and in the denominator will be, it is equal to 3C square. Okay, denominator it will be equal to 3C square. So C square will be get cancelled, and this capacitance. Okay, so while calculating the capacitance, it will not be C by 3. Sorry, something is wrong over here. It will not be C by 3. This capacitance will come as the 3C when you convert into the star. So that 2 star will come into the parallel. The 2 star will come into the parallel, that is CS. This CS will come in parallel with the star of this, so that is a 3CS, CS, 3CS, CS and 3CS. Suppose we want to measure the capacitance between, okay, so this is the parallel combination. When the capacitance are in parallel, the capacitance will be get added. So CAN capacitance will be 3cc plus CS, CBN also 3cc plus CS, CCN also 3cc plus CS capacitance. Okay, so CN capacitance, the capacitance with respect to the neutral of any phase is 3cc plus CS farad per meter, and the charging current is given by, we know that the charging current is equal to VPH, per phase voltage, divided by reactance, and reactance is given by, the reactance is given by 1 upon omega c. Okay, so I will tell you in term of omega c. So omega c will go in the numerator, so VPH into omega c. In this case, omega is equal to 2 pi f, and capacitance with respect to neutral is 3cc plus cs. So it is VPH 2 pi f 3cc plus cs ampere per phase. Okay, so that will be the value of the charging current. Once the charging current is known, we can calculate the charging kVA. Okay, so it is task to you. You determine the charging kVA of this cable. Okay, charging kVA of this cable if it is excited by the per phase voltage. Now, how to measure the CC and CS? So there are the different types of measurement. In the first measurement, all cores are shorted together. Means core 1, core 2 and core 3. It is a shorted together, and the capacitance is measured between any core and neutral. Capacitance is measured in between any core and neutral. See, as this is the shorted, the value of this CS is get bypassed, so it is become redundant. So CS will become a 0. So this is also become a 0. this is also become a 0 because it is a shorted. Okay, so means these two capacitance and these two capacitance, okay, so they will form, okay, they will form a parallel connection. So let's see how it will form a parallel connection. See, point A, point B, and point C are equipotential point because they are shorted. And with respect to neutral, I am measuring. So in between A and NCS, B and NCS, and C and NCS. So CS, CS, CS. Three capacitance are in parallel. So capacitance C1 is given by 3 CS because it will get added. CS plus CS plus CS. In the parallel, capacitance is always get added. So it is a 3 CS. So from this, how I can determine the value of CS as C1 by 3. So by shortening this, I will measure the value of C1, and to get the value of CS, I will divide the value of C1 divided by 3. Then I will get the value of CS. Okay, so hope it is clear to you how to calculate the value of the CS. Let's come to the next second measurement. We know the value of CS. Now we need to calculate the CC. In the second measurement, two cores are bunched together with the sheath, and capacitance is measured between the sheath and third conductor. See that uh, two conductors are bunched together with sheath. So C, B, and N are connected together. C, B, and N are connected together means this will become a 0, this will become a 0, and this will become a 0. So you will find that C and B are the equipotential point, C, B, N are the equipotential point. Hence CC, CS, and CS, sorry, CC, CS, and CC will be in the parallel. So we will draw the equivalent diagram. Okay, so we'll observe here B, C, N are the shorted point, A is the independent point. So between A and C there is a CC, between A and N there is a CCS, and between A and B there is a CC. So this is C2. So obviously what is the value of the C2? The value of the C2 will be CS plus CC plus CS plus CS, that is 2 CC plus CS farad per farad. So from this, how will calculate the value of CS? Okay, so from this, how will calculate the value of CS? CS is equal to C2 minus CC upon 2. So this CS, okay, so just a minute. Okay, so we have determined here value of the CS. Okay, CS is already known. Okay, so let me revise this formula. So don't look to this formula. I want to calculate the value of CC. So how will calculate the value of CC? The CC will be equal to C2 minus CS divided by 2. This formula is wrong. Please don't look to this formula. It is C2 divided by C2 minus CS divided by 2. It is in farad. So you will get the value of CC. In earlier measurement, we have calculated the value of CS. So from the earlier measurement, substitute CS, you will get the value of CC. So don't look to this. So what is the wrong into this? Here must be CC and here it must be CS. Okay. So hope it is clear to you. So this is my mistake. Okay. So come to the next slide. Suppose I want to measure the directly neutral capacitance, then it is also possible. How to measure it? Connect the one conductor with respect to the sheath, or connect one conductor to the sheath and measure the capacitance between other two conductors. See, this CS will become a 0. So what will be the equivalent diagram? You will observe that this C and N are connected together. A is independent, B is independent. So between A and B, you will observe that this is CS and this is the CS. So this is a CS and this is a CS. One more, this is a CC, that is a CC. Here you will observe that it is CC between the A and C, and between C and B there is one more. Okay, so between C and B there is one more CC. This is also what? CC. So CC and CS are in parallel. So this two will give you CC plus CS. This two will give you CC plus CS. And again it is added. Again it is added with the okay. And these two are in series. So as these two are in series, so when two equal capacitances are in series, the equivalent. Okay. So let me give you example. Two equal resistances are in parallel. Two equal resistances are in parallel, then the equivalent is the half of that. Similarly, when two equal capacitance are in series, the equivalent is the half of that. That means CS plus Cc plus Cs divided by 2 is this combination, this total combination. Okay, and it is in parallel with the Cc, means I want to add the Cc. So I make the denominator same, so Cc plus Cs plus 2Cc divided by 2. So this will give you me 3Cc plus Cs divided by 2. That is, I will take this 1 by 2 here. That is a 3Cc plus Cs. This 3Cc plus Cs is nothing but your neutral. Suppose you measure the C3, suppose you measure the C3, then Cn, neutral capacitance, is equal to 2 times of C3. Okay, so neutral capacitance is equal to what? 2 times of your Cc. So same is given here. So C3 is equal to Cc plus Cs divided by 2 plus Cs. So C3 is equal to 3Cs plus 3Cc plus Cs. So it is a 1 half of Cn. So Cn is equal to 2 times of your C3. So this is how you can measure the core capacitance and sheath capacitance. So let's summarize all points together. Capacitance is the significant in underground cable. Capacitance of single core cable is given by C is equal to epsilon r 18 natural log of r by r microfarad per kilometer. Capacitance of the three core cable with respect to neutral is given by 3 cc plus cs farad per meter. Okay, capacitance, different measurement techniques are carried out to measure the core to core and core to sheath capacitance, that is the CC and CS capacitance can be measured using here. Okay, so with this we are at the end of this topic. Hope you enjoy this video. Thank you very much.